Lesson 1.32 is on partial fractions, A-level pure maths, year 2. And this is the second in a series of lessons on partial fractions. Before I proceed, I would like to point out that the previous one, the first, was erroneously labeled as year 1 pure maths. It was meant to be year 2 pure maths. So please note that. In this lesson, we are going to explore some applications of partial fractions by solving 3 questions involving partial fractions. So question 1, g of x is equal to 3x squared plus 3 over 2x cubed minus 5x squared minus 4x plus 3. The graph of y equals to f of x has a vertical asymptote with equation x equals to minus 1. Use this information to express f of x as the sum of 3 fractions with linear denominators. Now, x equals minus 1. So x equals to minus 1 implies that x plus 1 is equal to 0. And because it is an equation of a vertical asymptote, it implies that some constant a over x plus 1 is one of the component partial fractions of g of x. Because when x plus 1 is equal to 0, as we've seen over here, then the whole of this fraction is undefined. And this gives rise to the asymptote. So this means that x plus 1 is a factor of this denominator here. So let's state that before we proceed. So x plus 1 is a factor of the denominator. So now we can use our knowledge in factor theorem from year 1 to find the other linear factors of the denominator by doing the long division. So I have 2x cubed minus 5x squared minus 4x plus 3 divided by x plus 1. If I look at this first term and that, I know that I need 2x squared over here. So that will be 2x squared. Then I'll multiply 2x squared by this and I'll get 2x cubed plus 2x squared. Then I'll do my subtraction and I'll have nothing here and I'll have minus 7x squared over here. If I bring down a minus 4x, I can now look at this and that, and I now know that the next term will be minus 7x. So that will be minus 7x. Then I'll do my multiplication again. This times all that. I have minus 7x squared over here and minus 7x over here. And then I will do my subtraction again. And then minus 7x squared plus 7x squared, that's nothing. And then minus 4x plus 7x. Because a minus times a minus gives you positive, so plus 7x. That will be left with 3x. And then I'll bring down the 3. And then if I look at this one and this term, I know that the next term will be plus 3. So I have 3 times all that gives me 3x plus 3. I do my subtraction again, and that will yield nothing. And so that means the denominator, 2x cubed minus 5x squared minus 4x plus 3 is equal to x plus 1 times 2x squared minus 7x plus 3, which is this times that. So now we need to factorize this one here to get 2 linear terms. So I have 2x squared minus 7x plus 3. I can split the minus 7x into minus 6 and minus x. So I have 2x squared minus 6x minus x plus 3. Then if I do my factorization, I'll have 2x brackets x minus 3, and minus 1 I have x minus 3 over here. Do your complete factorization, and I'm going to get x minus 3 and 2x minus 1. And so we can now replace this with the two linear factors over here. So the whole of that becomes x plus 1 brackets x minus 3 and 2x minus 1. So that's the denominator. So g of x now will be 3x squared plus 3, all of that over x plus 1, x minus 3 times 2x minus 1. That's g of x. So now g of x can be split into partial fractions as follows. 3x squared plus 3 over x plus 1, x minus 3, 2x minus 1 will be equal to a over x plus 1 plus b over x minus 3 plus c over 2x minus 1, as we've seen from the previous video. Now it's time to find the values of a, b, and c. So I'm going to multiply all the four terms by the denominator here. So if I do that, I'll be left with 3x squared plus 3 on the left hand side. So I'll have 3x squared plus 3 on the left hand side, and on the right hand side I'll have a bracket x minus 3 times 2x minus 1, because the x plus 1 will cancel that x plus 1. So plus b brackets x plus 1 times 2x minus 1 plus c brackets x plus 1 times x minus 3. Then we can do some strategic substitutions to find the values of a, b, and c. So we start with when x is equals to minus 1. I'll have 3 plus 3 is equals to a times minus 4 times minus 3. Because when x is equals to minus 1, all that will become 0, because minus 1 plus 1 is 0, and that makes the whole term 0. And similarly, the whole of this term will be 0, so I'll be left with it. If I evaluate that, I'm going to get 6 is equals to 12a, which implies that a is equals to 1 over 2. When x is equals to 3, then on the left-hand side, I have 3 times 9 plus 3 is equal to b times 4 times 5. Again, because the whole of this term becomes 0, because x becomes 3, and 3 minus 3 is 0. Same with this term here. But 3 plus 1 is 4, and 2 times 3 is 6. 6 minus 1 is 5. And that's why I have this. If I solve for b, I'll have 30 is equal to 20b, which implies that b is equal to 3 over 2. So for the next one, I'll say when x is equal to a half, then on the left-hand side, I'll have 3 times 1/4, because x squared is 1/4 plus the 3 is equals to c times 3 on 2 times minus 5 on 2. Again, because the whole of this term becomes 0, because 2 times a half is 1, and 1 minus 1 is 0. Similarly, same here, and this whole thing becomes 0. So this is the only term left. And if I evaluate that, I'm going to get 15 over 4 is equals to minus 15c over 4, which implies that c is equals to minus 1. So now I'll have g of x will be equals to half over x plus 1 plus 3 over 2 over x minus 3 minus 1 over 2x minus 1. If you simplify that, g of x finally becomes 1 over 2 brackets x plus 1 plus 3 over 2 brackets x minus 3 minus 1 over 2x minus 1. And these are the three partial fractions required for question 1. Question 2. f of x is equals to 1 plus 15x minus 10x squared all over x minus 2 times 1 minus 2x is equivalent to a plus b over x minus 2 plus c over 1 minus 2x. A. Find the values of a, b, and c. B. Hence, find the integration of f of x with respect to x. So first of all, we have to resolve this fraction into partial fractions. And I can use long division here, but instead of using long division to first find the value of a, I'm going to use a different method. And this will involve multiplying all the terms by this denominator here. So if I do that, I'll be left with 1 plus 15x minus 10x squared on the left hand side. That will be equal to a times x minus 2 times 1 minus 2x plus b times 1 minus 2x plus c times x minus 2. Because the x minus 2 will cancel out here, I'll be left with just 1 minus 2x. And then 1 minus 2x will cancel out here, and I'll have just x minus 2 left here. Then I can do some substitution here to find the respective values of a, b, and c. So first I'll start by saying when x is equals to 2. What I've got now is on the left hand side I'll have 1 plus 30 minus 40. That will be equals to b times minus 3. Because when x is 2, the whole of this term becomes 0 because 2 minus 2 is 0. And the whole of this term becomes 0 as well. And so I'll have this left. Simplifying, we give minus 9 equals to minus 3b, which implies that b is equals to 3. When x is equals to a half, then on the left hand side I have 1 plus 15 over 2 minus 10 times 1 over 4 will be equals to minus 3c over 2. Again, because this term becomes 0 when x equals to half, and this term becomes 0 when x equals to half. So let's simplify that. So I have 6 is equals to minus 3 on 2c, which implies that c is equals to minus 4. For the next one, I'll let x equals to 0. So when x equals to 0, on the left hand side, I'll have 1. And on the right hand side, I'll have minus 2a plus b minus 2c. Because when this is 0, I have this will become 1, and this will be minus 2, and then this will become 1, and that will become minus 2. That's why I have this here. But I know the values for b and c. So I'll do the substitution with those values. So I have 1 is equals to minus 2a. B we got to be 3. And c we got to be minus 4. So that makes it plus 8. And then I'll have 1 minus 11 is equals to minus 2a, which implies that a is equals to 5. So the values of A, B, and C as follows. So A is 5, B is 3, and C is -4. And so that's for A. So for B, I now know that f of x is equals to 5 plus 3 over x minus 2 minus 4 over 1 minus 2x. So the integral of f of x with respect to x will be the integral of 5 plus 3 over x minus 2 minus 4 over 1 minus 2x dx. Now, this can be integrated easily, and so is this one, but I'll take time to explain how this can be integrated using substitution, and then we'll come back to do this. So for this one, I've got the integral of 4 over 1 minus 2x dx. So I'll say let u equals to 1 minus 2x, and that means du is equals to minus 2 dx. I can now make dx the subject by saying minus half du is equals to dx. So I can rewrite the whole of this integration as follows. 4 integral of 1 over 1 minus 2x dx. So now the x can be replaced by minus half du, and 1 minus 2x can be replaced by u. And so I have times minus half integral of 1 over u du, because the dx has been replaced by minus half du. This 4 is over here, and then I have 1 over there and over u. This can easily be written as minus 2 integral of 1 over u du, which is equals to minus 2 ln u. So that can be replaced over here, and so I can now proceed to integrate the whole thing. And so this will be, if I integrate 5, I'll get 5x plus, if I integrate 3 over that, I'll get 3 ln x minus 2. And we just found out this one to be minus 2 ln u, which can be written as minus 2 ln 1 minus 2x. So now I can replace this one with that, and that will give me plus 2 ln 1 minus 2x plus my integration constant. I can use the loss of logs to simplify this further. I'm going to get 5x plus ln x minus 2 to the power 3 plus ln 1 minus 2x to the power 2 plus the integration constant. I can simplify this further using loss of logs again, and I'm going to get 5x plus ln x minus 2 cube times 1 minus 2x squared plus integration constant. And that is the final answer required. Question 3. F of x is equal to 39x plus 12 all over x plus 1 bracket x plus 4 times x minus 8, where the absolute value of x is less than 1. A. Express f of x in the form a over x plus 1 plus b over x plus 4 plus c over x minus 8, where a, b, and c are constants to be found. Hence or otherwise, find a series of expansion of f of x in ascending powers of x up to and including the x squared term. So for A, I have 39 x plus 12 x plus 1 x plus 4 x minus 8 is equal to a over x plus 1 plus b over x plus 4 plus c over x minus 8. If I multiply all the four terms by this denominator here, I'll be left with 39 x plus 12 on the left hand side, and on the right hand side I will have a brackets x plus 4 times x minus 8 plus b brackets x plus 1 times x minus 8 plus c brackets x plus 1 times x plus 4. So it's now time to do some substitution. So when x is equals to minus 1, I have 39 times minus 1 plus 12 is equals to a brackets 3 times minus 9. If you evaluate for a, you're going to get a is equals to 1. And then when x is equals to minus 4, I have minus 144 on the left hand side equals to 36b on the right hand side. Again, because this term will be eliminated and this term will be eliminated. And so this implies that b is equals to minus 4. And when x is equals to 8, I have on the left hand side 324 equals to 108 c on the right hand side, which implies that c is equals to 3. So it means a is equals to 1, b is equals to minus 4, and c is equals to 3. So now f of x becomes 1 over x plus 1 minus 4 over x plus 4 plus 3 over x minus 8. So for the expansion in b, I'm going to rewrite these denominators differently as follows. So x plus 1 will be written as 1 plus x. And then x plus 4 will be written as 4 plus x. And then I can factorize the 4 out to get 1 plus 1 over 4x. And then x minus 8 will be written as minus 8 plus x, which can be further written as minus 8 brackets 1 minus 1 over 8x. So now I can write the function as this. F of x is equals to 1 over 1 plus x minus 4 over 4 brackets 1 plus 1 over 4x plus 3 over minus 8 brackets 1 minus 1 over 8x. So we can write this as 1 plus x raised to the power minus 1 minus 1 plus 1 over 4 x raised to the power minus 1, because this and this can cancel. And then I'll have minus 3 over 8 times 1 minus 1 over 8 x raised to the power minus 1. We are now ready to do our expansion. So I'm going to take each step individually and expand them. But before I expand, I would like you to note the following: that minus 1 c0 is equals to 1 minus 1 c 1 is equal to minus 1, and minus 1 C2 is equals to minus 1 times minus 2 over 2 factorial, which is 2 times 1. And when you simplify that, you're going to get 1. So please note that we are going to need all that in the expansion. So for the first one, 1 plus x raised to the power minus 1. If I expand it, I'm going to get minus 1 C0 times 1 times x to the power 0. Normally, I'll raise the power here to minus 1 because the powers must add up to give you minus 1 here. But minus 1 raised to any power is 1. So I'll just leave it for all of them and just write 1. Plus minus 1 C1 times 1 times x to the power 1 plus minus 1 C2 times 1 times x squared. That will simplify to 1 because this is 1 and that will be 1 like we said over here. And then this will be minus x because minus 1c1 is minus 1 times x to the power 1 is x, and then plus x squared. The next term, 1 plus 1 over 4x raised to the power minus 1 can be expanded as follows. Minus 1 c0 times 1 times 1 over 4x to the power 0 plus minus 1 c1 times 1 times 1 over 4x to the power 1 plus minus 1 c2 times 1 times 1 over 4x to the power 2. This can be simplified too. So this is 1 times 1 times 1. So again, we get 1 here. And then the next term will be minus 1 c1, as we saw, is minus 1 times 1 over 4x times 1 will yield minus 1 over 4x. And this will be minus 1 c2 will be 1. That's 1. And then 1 over 4x squared is plus 1 over 16 x squared. The next term, so 1 minus 1 over 8 x raised to the power minus 1 can be expanded as follows. Minus 1 c0 times 1 times minus 1 over 8 x to the power 0 plus minus 1 c1 times 1 times minus 1 over 8 x to the power 1 plus minus 1 c2 times 1 times minus 1 over 8 x to the power 2. This will simplify to, again we get 1 here, and that would be minus 1 times minus 1, 8x. So that will become positive 1 over 8x. And then evaluation this one will be plus 1 over 64 x squared. So now f of x becomes 1 plus x to the power minus 1 can be replaced with this one. So I have 1 minus x plus x squared. And we have minus here, so the next term will be minus. And obviously, the whole of that will be replaced by that. So that will be 1 minus 1 over 4x plus 1 over 16 x squared. Then we have a minus here, so minus 3 over 8 brackets. And then we are going to replace all that with this. So I have 1 plus 1 over 8x plus 1 over 64 x squared. So I'm going to expand the whole thing by expanding these brackets here, and I'm going to get 1 minus x plus x squared minus 1 plus 1 over 4x minus 1 over 16x squared minus 3 over 8 minus 3 over 64x minus 3 over 512x squared. I'm now going to collect like terms, and I'll have 1 minus 1 minus 3 over 8 for the constant terms. And then for the x term, I'll have minus x plus 1 over 4x minus 3 over 64x. And for the x squared terms, I'll have plus x squared minus 1 over 16x squared minus 3 over 512x squared. So simplify the whole thing. Finally gives f of x is equals to minus 3 over 8 for the constant term minus 51 over 64x plus 477 over 512x squared. And this is the required series expansion up to and including the term x squared. And this brings us to the end of this session on partial fractions and its applications. Thank you again for watching. I'll see you in the next video.